In the previous video, I left one problem that I didn't get a chance to finish, but if I have time permits, I'll come back and do this last problem from the substitution method at the end of this video. But this video is actually going to focus on the elimination method. And in the elimination method, you want to try to add equations together, add them together term by term in order for a variable to eliminate. So let's start with x minus y equal 3 and x plus y equal 1. Now I call this the easy case because in this case you do not have to manipulate the equations here. In other words, you don't have to multiply the equations by any number. All you have to do is just add them. So if I take the first equation and add it to the second equation, you'll see that x plus x gives me 2x, and then minus y plus y gives me 0, so they just cancel, and then 3 plus negative 1 gives me 2. So in that case I have 2x equal 2, and then if you divide both sides by 2 you get x equals 1. And then you can take the 1 and plug it back into either one of these equations and solve for y. So if I plug it back into the first equation, I get 1 minus y equals 3, and then subtract 1 from both sides, and I get minus y equals 2, and then multiply both sides by negative 1, and y equals negative 2. So the answer is 1, negative 2. Now on this next one, you remember I solved this one earlier using the graphing method and the substitution method, but if I want to solve this by the elimination method, I'm either going to have to multiply the first equation by a constant or the second equation by a constant. Now, if I want to eliminate the x's, I can simply take this equation and multiply everything in this equation by negative 2, because if I multiply by negative 2, then that would give me a 2x and a negative 2x, so that when I added them together, the negative 2 would cancel. Now I could have also chose to multiply the first equation by negative 3, because then that would have helped me eliminate the y values, because I would have had a negative 3y and a plus 3y. So either one is fine, but obviously you don't have to do both. So if I multiply the second equation by negative 2, that's going to give me here negative 2x here, negative 2 times 3y is negative 6y, and then negative 2 times 9 is negative 18. Remember, you got to multiply all three terms by negative 2. Now here's the first equation. So now I can add these two equations together, and when I add 2x plus negative 2x, they just cancel. And then add y plus negative 6y, and I get negative 5y. And then if I add 8 plus negative 18, I get negative 10. So I get negative 5y equals negative 10. Then divide both sides by negative 5, and y will equal 2. And then I use the y to solve for the x, so go to the first equation up there, 2x plus y equal 8, and then plug 2 in for y, and you get 2x plus 2 equals 8. Then subtract 2 from both sides, and you get 2x equals 6. And then finally divide both sides by 2, and you get x equal 3. So the solution is x equal 3 and y equal 2. Now, the difficult one is when you have to multiply both equations. So here I have 3x minus 2y equal 8 and 2x plus 5y equal negative 1. Now, I'm going to choose here to eliminate the x's. So I know if I multiply 3x by 2, that would give me a 6x. And if I multiply the 2x here by negative 3, that would give me a negative 6x, so that when I add them together they would cancel. But remember, if I multiply 3x by 2, I have to multiply every term in this equation by 2. So when I multiply every term by 2, that's going to give me 6x. 2 times negative 2y is negative 4y, and 2 times 8 is 16. And then likewise, if I multiply this 2x by negative 3, I've got to multiply every term by negative 3. So negative 3 times 2x is negative 6x, negative 3 times 5y is negative 15y, and negative 3 times negative 1 is 3. Now I can add these two equations together, and 6x plus negative 6x cancels. and I have negative 4y plus negative 15y, that's negative 19y. And then I have 16 plus 3, which is 19. And then divide both sides by negative 19, and you get y equals negative 1. And then to continue, we got to use that y value to solve for x. So pick either one of these equations. I'll choose the first one, 3x minus 2y equals 8, and then replace y with negative 1. And so that's going to give me 3x minus 2 times negative 1 equals 8. And minus 2 times negative 1 is plus 2, so that gives me 3x plus 2 equals 8. And then if you subtract 2 from both sides, I didn't show that step, but if you subtract 2 from both sides, you get 3x equals 6. And then the last step, divide both sides of this by 3, and you get x equal 2. And so the answer would be 2, negative 1. So just like the substitution method, if you get an identity equation, in other words, an equation that's always true, there are infinite solutions. And if you get an impossible equation, there's no solution. Okay, let's go ahead and look at some applications here with this method. Here a man wants to use milk and juice to increase the amount of calcium and vitamin A in his diet. An ounce of milk contains 37 milligrams of calcium and 57 micrograms of vitamin A. An ounce of juice contains 5 milligrams of calcium and 65 micrograms of vitamin A. How many ounces of each should he consume daily to provide exactly 500 milligrams of calcium and 1200 micrograms of vitamin A? Well, let x be the number of ounces of milk, and let y be the number of ounces of juice, because it says how many ounces of each, so we can let those be the variables. Now let's draw a table here. For calcium, the milk provides 37. Now this table right here, I'm sorry, I should explain this. This is actually the this is the calcium. So for the milk, the let's see, the milk has 37, right? So an ounce of milk contains 37 milligrams of calcium. So each ounce of milk contains 37 milligrams of calcium. And then an ounce of juice contains 5 milligrams of calcium. So your juice contains 5 milligrams of calcium. And you have to have 500 milligrams of calcium. So we have that if you multiply the 37 times the number of ounces of milk, and then 5 times the number of ounces of juice, then that actually represents the total amount of calcium that you get, and that has to equal 500 units of calcium. And then for vitamin A, the milk, each ounce of milk gives you 57 micrograms of vitamin A, and each ounce of juice gives you 65 micrograms of vitamin A, and you have to have a total of 1200 micrograms of vitamin A. So multiply 57 times the number of ounces of milk plus 65 times the number of ounces of juice, and add those together, and that gives you the total vitamin A, and that has to equal the 1200 units of vitamin A required. So now, to solve this, all I have to do is figure out a way to eliminate the x's or the y's. Well, the 37 and 57x, that's kind of hard to do. It's kind of hard to figure out what would make those eliminate. But the 5y and the 65y, I can figure out a way to make those eliminate, because I know if I multiply 5y by negative 13, that would make it equal negative 65. So I'm going to multiply everything in this first equation by negative 13, and I'm just going to leave the second equation as is. Now, when I multiply this, negative 13 times 37x is negative 481x. Negative 13 times 5 is negative 65y, and negative 13 times 500 is negative 6500. And then if I add that to the second equation, notice the y's will cancel, and negative 481x plus 57 gives me negative 424x, and negative 6500 plus 1200 gives me negative 5300. And then I divide both sides by negative 424, and I get x equals 12.5 ounces. So that's 12.5 ounces for x. And then just plug your x back into this first equation here and solve for y. So I have 37 times 12.5 plus 5y equals 500. Well, that's 462.5 plus 5y equals 500. Subtract the 462.5 from both sides, and I get 5y equals 37.5. And then divide by 5, and you get y equals 7.5 ounces. So the answer would be 12.5 ounces of milk and 7.5 ounces of juice. Okay, now I also want to show you that when you saw this example, you saw this is the first one that I did where the numbers didn't come out to be integer values, they came out to be decimal values. Well, let me show you that the numbers certainly can even be worse than that. So let's say I wanted to solve this system of equations. Well, I'm going to eliminate the y's. So I'm going to multiply the first equation by 4, and I'm going to multiply everything in the second equation by -3. And so when I multiply everything in the first equation by 4, I get 20x plus 12y equals 40. And if I multiply everything in the second equation by -3, I get -9x minus 12y equals 6. Well, then if I add those together, if you add these together, 20x plus -9x, you'll get 11x. And then if you add 40 plus 6, you get 46. Of course, the y's cancel. And so you get 11x equals 46. So x is 46/11. So not a nice round number. And then when you plug it back into the first equation, you get 5 times 46 over 11, and then plus 3y equals 10. Well, that's going to give me 230 over 11 plus 3y equals 10. And then subtract both sides by 230 over 11, and then convert 10 to something over 11. Well, 10 can be written as 110 over 11. So then you have 110 over 11 minus 230 over 11, which gives you -120 over 11. And then divide both sides by 3, or if you prefer, multiply both sides by 1/3, and the 3 will divide into the -120, giving me -40 over 11. So there you can see that we don't always get nice round numbers. Okay, what I want you to do on these two is just pause the video and read them and just see how I set up the equations. And notice that each one of these problems you set up an equation. So the first one, the solution would be found by setting up the equations x plus y equals 500 and 2x plus 3y equals 1350. And the second one, you would have x plus 2y equals 20 and 2x plus 3y equals 30. So I didn't ask you to solve these. All I asked you to do was just set up the problems. So again, pause the video and read them and make sure you can understand how I got these equations. Because I wanted to take the time now to show you one more example on a dependent system. So I'm going to go ahead and move on to this last example here of a dependent system. So if you solve this system here, 2x minus y equals 5 and 6x minus 3y equals 15 by the elimination method, you could multiply the first equation by -3, and then that would give you minus 6x plus 3y equals -15. And when you add it to the second equation, notice that everything cancels. Everything cancels. So on both sides, you actually get the equation 0 equals 0. That's a dependent system. So both equations represent the same equation. So here's what I'm going to do here. I'm going to take the first equation, I'm going to solve it for x in terms of y. So if I solve it for x in terms of y, it tells me that x depends upon y. And if x depends upon y, then that means whatever y is, x has to be related to it in this fashion. So x would be 1/2 y plus 5/2. So y is going to equal y, where y is any real number, and then x is going to equal 1/2 of y plus 5/2. Now actually I could use any letter to represent y as long as I represented x using that same relationship. So if I let y equal k, then x would be 1/2 k plus 5/2, where k is any real number. Okay, so now the next section, it might be an optional section for your class, but it's going to be solving systems that have 3 variables and 3 equations. I'll do that on the next video.